So we're going to move on. And this is task O0204. So Oscar 0204. And this task is found on page 4 of the task guide. So anyone using a GPS these days knows pretty much lat and long, or latitude and longitude. Let's take a look at it, at the world from a latitude and longitude perspective. Lines of latitude run horizontal or east-west. Think of a ladder. When you step up and on a rung, you're going up or down. Where is 0 degrees latitude? Who wants to take a guess at that?
Equator.
Equator.
At the equator, exactly. So now's the trivia question. Anyone know what town is at 45 degrees latitude in Michigan?
Gaylord or Galen or Gaylord. It's up there just before you get in the Upper Peninsula. Up in the lower peninsula.
I love that it was a member from Iowa that answered that question. Awesome. Yeah. As a matter of fact, when you're coming,
sure, I told you I lived there for a few years. I mean,
that's true, you did. So yeah, you see it right when you're traveling on I-75. There's that big map, right? 45th parallel, which is, so when you're standing at that sign, there's an importance to that. You're actually halfway between the equator and the North Pole. Oh.
That was from the Salford Squadron.
Okay. I still haven't figured out where I know somebody had that at one point. You could mute everybody. I don't know where that button is. So I do know how to mute people individually, but not as a whole thing. So right. So choosing the equator as the 0 point is pretty self-explanatory. Lines of longitude run vertically or north and south. Whoops, sorry, let's try that again. So choosing the equator as the 0 point is pretty self-explanatory. Now, lines of longitude run vertically or north-south. Where is 0 degrees longitude? Anybody know where the prime meridian is?
Yeah, it's Greenwich, England.
Greenwich.
Greenwich, England. Correct. Anybody know why?
They were there first.
Kind of, sorta. There's actually a long history as to why the town of Greenwich was used as the anchor. And we'd be here for a pretty long time if we went to all of it. But the short answer is that England had the world's largest naval fleet starting from the latter days of the medieval times. Other countries and cultures began using the same system. So by the 19th century, 72% of the world's commerce depended on sea charts, which used Greenwich as the prime meridian. So by being advantageous to the largest number of people at the time, it remains to this day. Now, the town itself is not much to speak of. It's about 67 square miles, has a population of less than 50,000. So where exactly is ground zero? Obviously, you've got 67 square miles. There's, where is 0 degrees exactly? It's actually found at the Royal Observatory in Greenwich, right in the crosshairs of the telescopic site. Since that never moves, if you're looking into that telescope, you are at absolute 0 degrees longitude. All calculations of longitude are based on that location. So everybody understands lat and long, right? Or latitude and longitude. You'll find I say longitude, some people say longitude. So I'm not going to correct anybody. So both latitude and longitude are measured in degrees, minutes, and seconds. 1 minute is 1/60th of a degree. 1 second, anybody want to guess?
1/60th of a minute.
Exactly. So that's nice, but how far is that? Well, that depends on where you are. Note, whoops, I thought so. Note that our globe here, the latitude markers remain pretty much constant. So if we look up, we go here, we'll see that this to here is the same, 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 this to here is the same. It's pretty much constant where the longitudinal markers, but where the longitudinal markers, they converge at the poles. So up here, there's only this much room, but down here, there's this much room. So for this reason, the closer you are to the equator, the more equal the size will be of the latitude and longitudinal square. So down here, you're pretty much looking at absolute squares. Over here, you're looking more at rectangles. Might make sense? All right. So with that, in Michigan, for the most part, we see that 1 second is equal to about 101 feet in latitude, but 80 feet in longitude. A minute is equal to about 1.15 miles latitude and 0.91 miles longitude. And because of that, a degree is 69 miles latitude, but only 54.6 miles longitude. So in the continental US, latitude numbers are read from north to south, bottom to top. Longitudinal numbers are read from east to west or from right to left. It makes sense because we are north of the equator and west of Greenwich. So it makes sense that in North America, each line of latitude is labeled as north, and each line of longitude is labeled as west. To read coordinates, we use the symbols of the little zero, the little O there, the one hyphen, and the double, not hyphen, what's the word? I can't remember the word. The apostrophe, thank you. So we use the one apostrophe for minutes and the double apostrophe for seconds. So we always read the latitude before the longitude. For example, these coordinates are read as, somebody's got to mute themselves, so they've got two things going. So for example, these coordinates are read north, 43 degrees, 20 minutes, 44.5 seconds, west, 86 degrees, 16 minutes, 49 seconds, longitude. Depending on the nature of the situation, you may have to express it as a decimal, in which case it would be 43.3457 degrees north, 86.2803 degrees west. Another form of decimal expression is to state the degrees in full, but the minutes as a decimal. So in this case, it would be 43 degrees, 20.7413 minutes north, 86 degrees, 16.8167 minutes west. Okay. To enter or search a geocoded map, which doesn't recognize north, south, east, west coordinates, we express a negative when we are west or when we are south. So in this case, our coordinate would look like this: 43.3457, comma, negative 86.2803 degrees. If we were south of the equator, then we would say negative 43.3457. If we were east of Greenwich, so if we were in Europe or Asia, we would be at 86.2803 degrees. Does that make sense? Everybody understand that? So in North America, which is where we're going to be for the most part, we're always going to have a positive latitude and a negative longitude. Okay, so why did I show you all of these? Because you always have to have the appropriate type of bearing based on the reason why you're giving the bearing. So the circumstances will dictate which form you use. You should be familiar with all of them. Now, I have a wonderful app on my phone, and you can key in any one of these and ask it to come out with any one of the other three. I suggest everybody grab one of those. They're a great little tool to have. So you can either input it as the first option here, and it will give you the decimal if you need it. If you only have the decimal but need this information, it will give it to you, and so on and so forth. So you tell it what you have, and then it will give you what you need in the other three versions. Any questions so far?
I have one, sir.
Yep.
Which standard does CAP go off of? Because I know
All four.
Yeah, I've been to a few star axes, and you will hear every one of those versions. And I just
Correct.
wanted to see if we've standardized on any particular one, but okay.
I think if you pay close attention, you'll notice that the standardization comes with the usage that you need. So
Right.
For example, ground control will probably go with the first kind, okay? Whereas air is probably going to be using this one here, the second version. When we code our pictures, most of them are coded in this version. And then of course, if we need to look up something on Google or somewhere, you're going to be using this version.
And Captain, I'll confirm that for the air side of things, we do the decimal seconds.
Yep,
That's how the Garmin G1000s are set up.
exactly. That's how I do that's also how I do my geocaching too. All right. So again, I've got a lot of pilots in here. I know and it surprises me that when I see this is not part of the pilot's training, and yet I would have thought that all the pilots would already be green on this. So you guys already know how to do this. So this is going to become a piece of cake. For those who have never had to do any of this, never did geocaching, never did anything in that regard, this is going to be a fun little exercise that we're going to do, because we're going to now put it into practice. Okay. So that I use that coordinate on purpose because it's now part of our lesson here. So we're going to use that coordinate to find a place on the map. So we have to start by getting to the right area. So if we know, I mean, this is a way of breaking things down, breaking down the degrees, the minutes, the seconds. It's not typically how you're going to do it, but if you have this in your brain, it's going to be a lot easier for you to get to the final point later on. So if you can't remember how to do that, the lat and long, this is going to be a neat little exercise for you to remember where you go. Okay, so in this, we're going to north 43 degrees, 20 minutes, 42.5 seconds, west 86 degrees, 16 minutes, 54.5 seconds. So our coordinates are on the left-hand side here. We're going to start with this. So what latitudinal degree do we want to start in? Which grid do you think we want to be in? A, B, or C?
B. B, sir.
B?
Yes, sir.
We're at 43 degrees,
It'll be A.
20 minutes.
It'll be A.
Maybe A.
A, right? Because 43.5 would be 30 minutes. So anything north of this would be 43 degrees, 30 minutes,
Okay, I got you, sir.
right? So we want to be in A. Very good, people. All right, so now we've got the latitude. What about our longitudinal grid? What are we going to use? 1, 2, 3, 4, or 5?
Four.
Got one for 4.
4.
Two
How
for
about
four. 2 for 4.
Yeah, exactly. All right. So we're going to drill down to this location here. All right. So we're down there. So let's keep going. What grid do we want to look at now? Are we, remember, 43 degrees, 20 minutes. So are we in A, B, C, or D?
B, D.
Yeah,
C.
Delta.
Everybody agree with Delta?
Yes.
All right, perfect. All right, so now we're looking for 86 degrees, 16 minutes.
Two.
Grid
2.
2,
Two.
exactly.
It'd be 2, sir.
All right, so we now know that our location is somewhere in this grid. So let's bring it down again. So we figured out the degrees, so let's narrow down the minutes. We're looking for 20 degrees, 42.5 seconds.
42. G.
Yeah.
G.
G,
I think it's F.
F, all right. So
Where's F? Yeah.
who's going to agree with who? I'm basing on
F.
that voice. That sounded like a cadet's voice. Is that a cadet?
Yes, sir.
All right. So who's going to agree with the cadet?
Me.
I will, sir. It's Foxtrot.
It's Foxtrot. Exactly. Way to go, cadet. All right. So now we're going to look at that. We're going to do the same thing. We've established the 86 degrees west. Now we want to find 16 minutes, 54 seconds.
3.
3.
3.
Three.
Three.
Yeah.
3.
3, sir.
Right on. We've got that area. Let's drill her down even more. So we've got the minutes. We've got the degrees. We got the degrees. We've got the minutes. Now let's see if we can concentrate on the seconds. All right. So we're now looking for 43 degrees, 20 minutes, 42.5 seconds, 86 degrees, 16 minutes, 54.5 seconds. What do you think we're looking for? And the coordinates are up
Anderson
top in
Woods.
case you need to look at them.
Be the park.
Would be the Anderson Woods Nature
Or
Preserve.
nature preserve there, or what is that?
Excellent. Very good.
Yeah.
Because again, if we take a look, we're going to 42.5. So it's going to be somewhere in there. And then we're looking at 86, 54.5. So pretty much right in the center of the Anderson Woods Nature Preserve. All right. See, I had you going in a different direction. You guys were all looking at the left-hand side. So let's go look at that. What do you think? What do you think the complete coordinates? Somebody give me the complete coordinates of Michigan's adventure. To the, plus or minus. We know the minutes, we know the degrees and minutes are the same. So that's going to be easy. What I want you to do is give me the degrees, minutes, and the seconds for Michigan's adventure. Who wants to venture a guess there?
Oh, what? North 43 degrees, 20 minutes, and 44.4 seconds. Guess.
Pretty close, yeah.
And then west, I'll let somebody else do that part.
I would say it's 86, 16, and 49
Yep,
seconds.
very good. So that's how you find locations. It's also how you expect a coordinate from a location. If you've got a map that's precise enough, you can actually figure out those coordinates right down to the second. Any questions? All right, so following coordinates is actually pretty simple, right? So there being no everyone in the meeting, I have put the quiz link in the chat, and I'll give everyone 5 minutes to complete that. And then if you, like I said, if you want to turn off your cameras, feel free, but I'm just going to ask you to turn your cameras back on when you come back, so that I know everybody's present.